Draft science video. Uh, Physics, of course, and unfortunately, it's all I got. Half a day to make a physics style video, and it was sort of on a subject I find interesting, which is the reflection of light. Um, and he was just dealing with the math of the probability that is created by this phenomenon. Newton's glass is kind of the way it's described best, but it really is the quantum mechanic effect, illustrated also in the two-slit experiment and these other things that have a probability tied to outcomes. So this glass phenomenon has a couple of elements to it. So depending on how thick the glass is, so at certain thicknesses, it becomes more or less reflective to certain wavelengths of light. So if you're using regular white light, it'll always be 4% because it has a mixture of all the different wavelengths. But if you use monochromatic light, one wavelength of light, you can see that as you thicken glass, it will change. It's the amount of light that doesn't get transmitted through the glass but reflects. And that reflection will go from 0 to 16%. So the 4% average is turned into 0 to 16. And this holds true no matter how thick you go. So if I just use big numbers to make it easier, if I go at 1 inch, I would be at 0. And then if I go an inch and a half, I would be at 16. So at 0, let's say blue light, at 1 inch, blue light will have 0 reflection at 1 inch, let's say, and that at 1 inch and a half, it'll have 16% of the blue light will be reflected. And then at 2 inches, it would go back to 0 again. And then 16, then 0, then 16, then 0. Sine wave. So that's the probability. Now, in Feynman's describing this, he's using this idea of a clock. He spins it backwards for whatever reason, I don't know. But, he's a Feynman. What the clock is representing, in a sense, is distance being traveled, but it's really not. It's because different things reflect different ways. The reflection of light off of glass, and off of it is a key word, I suppose, is different than when something's inside the glass, like in water, where you stick a pencil in and the light gets refracted at a bent angle. That phenomenon is different than what could be called surface reflection. Now, in Feynman's explanation, at first I thought he was, at first I was saying, well, why don't you just tell us the truth? And because he changed the story a little bit. He said, okay, I gave you the simple answer, that there's an infinite, like the light is reflecting at all different layers of the glass. And he was just basically talking about the top surface and the bottom surface. But ironically, the light doesn't reflect different levels of the glass. It reflects at the surface. And it only reflects at one surface, the top surface. And the idea of this timing cycle is still used, because the timing cycle is a reflection of what's happening to the atoms in the glass, that their cycle is changed. So, so it still holds as if the light traveled the distance, and then, it's a longer distance, therefore more time, therefore more clicks on the clock, and so that the vector changes, and that changes your probability math. So the idea of modeling, see the sort of a problem here is they're using different models, schema, however you want to describe it, to represent different phenomenon, and none of the models are accurate to the actual reality. So I mean, he's using a position model vector to illustrate distance, and that with different distances you would have different conditions, just as with different time in a cycle you'd have a different condition. So the argument I would make is that what's happening in this glass phenomenon anyway is that I think it can be established that the reflection is a surface phenomenon. So by changing the thickness of the glass, you actually change the atomic structure of the surface. The surface essentially records, has evidence of the thickness built into its disposition. So its shape, the shape of the surface atoms will be a reflection of how thick the glass is. And that's caused, in my opinion, by the fact that the atoms have a natural state, an ideal state, or shape. And when you change the thickness, you can only get so many of them in that, and they can't be perfectly shaped anymore. And the ones that get misshapen are the ones on the surfaces. And part of that is essential to glass being actually transparent, for glass not to scatter. So any irregularities in the surface will create scatter in transmission, and the two surfaces have to be opposite reflections of each other in a sense. They're like translators for the transmission of the light, because the light doesn't go through the glass straight. So whatever bends it starts taking, it has to unravel it exactly the way it raveled. So exactly the way it started, like if it went into the glass and it first took a left turn, it has to leave taking a right turn to have an accurate reflection, kind of a thing. You have to accurately represent the angle that the light came in at, the specific point it came in at. So to accurately reflect it, there has to be something that's going to translate all the zigzags back into the light coming out the right way, straight, out of the other side of the glass. This is a hard way of saying that. So anyway, they have these experiments where they slow down light, so to speak, by creating a glass material that creates more distance for these photons to have to travel. So my argument would be is that when light goes through a layer of glass, the light doesn't just go straight through. It quite, I think, obviously, is being grabbed by the atoms and is riding on the atomic forces of the atoms, and this is what slows the light down. 40% slower than the speed of light. Quite a bit. Light is slowed down rather substantially as it travels through certain mediums, like the transparent mediums. It's not an insignificant change, but the change is the result that this obviously is a much longer distance than this straight line, and it's this extra distance takes extra time. So the light itself is still moving the speed of light. It's just taking more time because it has to swing around all these orbits inside all the atoms as it's being transmitted. Now what's happening with the reflection is that, you have to kind of think of it as marbles, and that marbles are rigid. And so if you had a container that was a certain size and you put 4 marbles in, let's say, well, if if the container is too small, the marbles will become irregularly positioned, and so they won't be able to fit. So what's happening in glass is they're not doing this. They're not they're not rearranging. Each atom doesn't rearrange like this. But what happens is that the force of compliance to this to the shape is affecting only the surface atom, and these are the ones that get misshapen or atomically changed in some way. So you could almost say they acquire a charge or some other thing changes about them. They have more ion. They have more electrons, are more likely to be at the surface. But the key point is that we know that. Sorry, I have to hit this stupid Google update bullshit. Is that this shape change, or this, we almost see it as a vibration. You know, that this just keeps bouncing back and forth through the, it forces it to become energetic. So as you change the shape, as you put pressure on the atoms, they increase their energeticness, and that's reflected on this surface as a, you know, as a frequency of movement. And now, depending on what frequency light is hitting it, depending on what position it's in, it will now be able to capture it or unable to capture it. So essentially what's happening is the orbits, let's say on these surface molecules, so here's the surface molecules, the orbits are expanding and contracting, let's say. So here's the full expansion and here's the full contraction. At this contraction level, it will completely, it will attempt to absorb the photon and capture it, but it can't hold it, and so it reflects it because it can't hold it. It doesn't reach a sufficient, it doesn't expand, it doesn't create higher energy. And so because it can't get to the proper energy level, it can't hold the photon it grabbed. This is a common kind of phenomenon where photons will go in, they can't be held, and they're released maybe in two different colors. And that's the reflection. And so for ultraviolet light, when it's at the smallest position, it tends to have this, you know, greater capacity, the 16% capacity to reflect the light. And at this widest position, it has a 0% chance of grabbing ultraviolet light. And the inverse would be true for, say, infrared light. At this point, it has a 0% chance of grabbing it and holding it. And at this level, it has a 16% chance of grabbing it and holding it. So for red light, it can grab it at this widest, and for ultraviolet light, it can only grab it when it's at the narrowest and release it. And that is having nothing to do with the transmission of the light that isn't grabbed. So the light that isn't grabbed is doing this outside thing. It's running around the outside of the atoms. It's the light that gets, that finds that hits the right position of the orbit. You know, it's like a meteor coming into the solar system. Most of the time it's not going to hit anything, but if it gets close to an orbital position, then it can be grabbed by the gravity if it has the proper velocity. So it's that kind of argument. If it comes in the right position, it will be grabbed. But like comets and stuff, sometimes it's grabbed and then it's thrown loose and it ends up being 100 years before it'll ever come back again, because its gravitational connection is not, you can't grab it permanently. You can't make it a satellite, a true satellite. So my argument is that what's creating the probability is a change in the dynamic, the mechanical dynamic of the surface molecules. As you change the thickness of the glass, you change the pressure that the molecules are under, which changes the orbit, the orbital compression, however you want to describe it, the strength of the atomic structure, its capacity to grab light at different energy levels. And it just cycles constantly through that pattern. And so, yeah, it's there. So the idea is that the argument I would make is that there is no, it always is on the surface though. The surface molecules would decide 16% or 4%. Because with the glass experiments, the slowing light down experiments, the idea when you create a foot of glass, of this special kind of glass, and you can slow light down 500% or, 10,000%. But in those experiments, I don't think there's been any evidence that they slowed down the reflection of light. That reflected light leaves with a delay that's substantial. So the light being reflected isn't going through some slow thing here and then flying out here. So there's no evidence that the light is being reflected at different points in the glass. Truth is, it's reflecting right off the surface. Now, like I said, this surface reflection is a different reflection. It's a different phenomenon than reflections where you have an object inside of, like a layer of water, and the light is actually being transmitted through, and it would go straight through the glass, so it wasn't reflected at the surface, and instead it goes through the glass as if it was going to be transmitted, and then it hits the impurity. So this has to be understood. When there's an object inside of something, it's an impurity, and now it creates it'll break the transparency, and now that's a different kind of reflection. That's not a surface reflection anymore. That's an opaque impurity reflection, and now it has to travel back out of the glass. So there's clearly it's going to travel out different than it traveled in many cases, because the distance is going to be different. The angle, unless the thing is in a perfect angle where it can reflect at exactly the same angle, these two distances won't be the same, and that's what will cause the distortion you see when you stick a pencil in a glass of water. Alright, so I don't want to do a whole bunch on this, but so I'm saying this probability can be modeled with something real instead of something fake. A model that's more representative of what's really happening, which is, let's just call it the expansion or contraction of a orbital of the atom, in the atom of the surface molecules. Their energy levels change through a cycle, and as you make the glass thicker or narrower, you change the likelihood that you change the what would be the right thing to have the right way to describe it. You change at what point that cycle is at. So the thicker you go, the cycle, I don't know exactly how to describe it. It's not vibrating faster, so I'm wrong to imply that as you get different levels it goes faster or slower. It's just merely that idea of that compression changes, and there's no it just changes in the sense that it goes from this to this as a maximum. So there's this amount of change, and this amount of change equals 16% reflection or 0% reflection. And all that's really changing is depending on how much pressure these surface atoms are under will dictate what light will reflect. So as they get more compressed, it's going to so different, exactly. So different thicknesses of glass will affect different light. So the same thickness, 1 inch, will only do the 16% for red light, and for blue light it would be a 0. But the 1.5 inches now creates a different pressure, so that would be, let's say, the biggest orbit now. And so now the red light's out of luck and the blue light's going to get reflected. So, yeah, I think it's simple enough to say, forget about the idea of even having to. I think it has to be communicated from surface to surface. The pressure has to be communicated through the two things. But the point is the only atoms that get affected by this are the surface atoms, the end atoms, the last atom, the ones that are the transition between empty space and the structure they're atomically connected to. The rest of the interior atoms, like you could argue, have the advantage of being connected at both ends. They have like a plus and a minus pole, and those poles are connected to minuses and pluses. They're bound to each other, where the surface molecules are not bound, and therefore on one end, so they can change shape. So the ones interior can't change shape, the ones exterior can. It's simple enough to put it that way. And it's that shape change that creates the probability. And the shape change varies depending on how thick the glass is. Right, I think it's enough. Alright, till next time.